Okay, so today we are going to talk about finding the slope. So last time we talked about slope using the formula, right? So they're using the slope formula. So now we're going to say, hey, how can I find the slope from an equation? Okay, so here's what we're going to do. We're going to take this general form, or excuse me, standard form of an equation. So we've got 4x plus 3y equals 12. And we're going to find the slope of the equation. So the first thing we're going to do is we're going to solve for the a part. Okay, so here's what we're going to do. By using the slope formula, we know, right? We know that the general form is going to be f of x equals ax plus b. Okay? Now, a is what we're going to call is the slope. Okay? And so we can easily find this by plugging in two values. If we take x1, so let's call f of x1, so let's say this is y1, right? We call it, since it's a function, f of x1. And we say y2 is equal to f of x2, and we're going to write it this way. So we know the form of a function can be written if it's a straight line. Again, we're assuming this is a straight line, right? So we know from the previous videos that we can write this function in the form of ax plus b. Each of those, right? Okay. Okay, so in this case here, these are 2 points on the line, right? So we have a line, and let's say these are the 2 points on the line. So y1, or excuse me, x1, y1, and x2, y2. So all I'm doing is I'm going to derive and show you that the slope is the a variable. Okay, so what I'm going to do is I'm going to just write this out. So I'm going to write the change in f of y, so f of x2 minus f of x1 divided by x2 minus x1. Now if I just plug in these two values into the formula, what do I get? I get ax2 plus b minus ax1 plus b over x2 minus y1, or excuse me, x1. So now all I did was I substituted in for these variables. Now, again, I'm going to distribute the minus, right, because I'm subtracting this whole thing. So now what's going to happen is this is going to become ax2 now plus b minus ax1, oops, minus b over x2 minus x1. Now here's where the magic happens. Now this is going to cancel with this. And now I'm going to get ax2 minus ax1 over x2 minus x1. And now watch what happens. Now I can factor out the a, right? And I end up with a x2 minus x1 divided by x2 minus x1. And so this cancels with that, and I get a. And I'm done. So all I did was prove that the slope in this form, the slope of a line, is going to be the a coefficient. So now, all that to show you this. So all I have to do is, if I have an equation in standard form, is I have to make this into y equals ax plus b form. And we're going to call this the slope-intercept form. Okay? Because this is the slope and b is the intercept. So all I have to do is solve for y. That's really what it comes down to. So let's solve this for y. So I'm going to just subtract 4x from both sides. And then I'm going to get 3y equals negative 4x plus 12. And now I'm going to divide everything by 3. And so I get y equals negative, now I'm going to split this up into two fractions, right? Because I want it in y equals mx plus b. So I want it in this form, okay? So now, oops. Okay, so now it's going to be negative 4/3 x plus 4. And that's it. So now I know that the slope is negative 4/3. And I'm done. And so that's how you do it. So anytime you have something in standard form, you can find the slope by just taking it and put it into this form. And from now on, what we're going to do is, instead of ax plus b, now we can say, hey, it's mx plus b. And so this is the slope-intercept form of the equation of a line. And so that's how you find the slope from an equation. And that's it.